Welcome to Water Supply and Wastewater Engineering class. So we are discussing in Unit 3, that is different processes in the water treatment plant. So in this unit we have discussed how the water is being treated on a treatment plant, what are the different chambers available, how water passes through from one chamber to another chamber, and ultimately it gets purified. So in the previous lectures we have seen the initially when the water comes from the raw source of water. So the first step is we provide the screen. So the basic purpose of screen is basically to filter out the floating objects which is present on the water. So once that is cleaned up, the next step is the aeration. So we have seen in the earlier lectures that aeration is a process where basically we are removing the toxic gases present in the water, as well as we are adding as much as possible oxygen from air to the water. Now, after aeration, water goes into primary sedimentation tank, and here also we have seen the principle of settling, how the molecules, how the solid molecules are simply settled down into the bottom because of the force of gravity. We have seen the different types of chambers, the different types of sedimentation tanks, a circular one or a long channel type basin. So all these things we have discussed in details. Now in the last few lectures we are discussing about how to remove the fine suspended particle present in the water. So as we have seen that the small suspended particles will be present in the water. So this is the water, but the small suspended particles will be still present in the water. So those type of particles won't settle down into the bottom in the primary sedimentation. Why? Because the mass of this particle is very less, and also the particle is very fine, so it exhibits the Brownian motion into the water, and it will always roam into the water. So how much time we keep on a rest condition to this, what to do the water, this particle won't settle down. So we have to do some of the secondary treatment, where we have to remove all these particles, small suspended particles also. So we have seen the what are the properties of suspended particles. So based on their properties, basically we are applying some extra chemicals that we call it coagulant. So in the last lecture we have seen the theory part of coagulant. So coagulants are basically added into the water, and because of this coagulant, the parts or small particles are actually charged up. Either it may be positively charged or it may be negatively charged, and we make the flocculation. So basically flocculation is basically the transportation of these particles along the water. So basically we are destabilizing the ions present in the water, and ultimately when this collides each other, so it will be combined. The size of this particle will increase gradually because it attracts the nearby particle, and ultimately it gets settled down. So when the size will be again increasing, so because of gravity again we'll be keeping it on a or keeping it on a rest condition for some time, and then it will be settled down at the bottom. So that theory part we have seen in details in the last few lectures. So in this is the last lecture on coagulation and flocculation topic. So here we'll be seeing, once you add this coagulant into the water, how exactly the reaction takes place, and how the and what is the optimum coagulant quantity we have to add into the water. So coagulant is nothing but some extra chemicals, like these are the salts of aluminum and iron. Why we provide aluminum and iron? Because these have a this electron, because of its electron configuration. Basically these salts are very suitable because it has a free electron. So when the salts of aluminum and so iron is added into the water, it dissociate to yield trivalent ion. So basically it has extra, that is trivalent ion it will produce, and when hydrate to form aqueous metal complex, such as this type of complex compound it will create once it reacts with the water. And then these complexes are then passed through the series of hydrolytic reactions, in which hydrogen molecule in H2O molecules in the hydration shell are replaced by OH minus ion to form a variety of soluble species, such as that aluminum oxide and ferric oxide. So this will be Fe. Okay. So basically what happens, this aluminum and iron are actually reacting on a water, and and after repetition of processes, with the water H2O molecule, basically it creates and ultimately OH minus ion replaces, and ultimately this type of ion you will find present, freely available on a water. So this type of complex particles or complex ions are basically attracted by the suspended particles. So here you see in the water these small fine suspended particles are there anyway, it is present. So when this type of complex ions are produced because of this chemical reaction, so these ions are actually absorbed by this each particle. So this suspended particles will absorb these ions because the particle is very fine. Very fine means very small. So it has, we have seen the properties of suspended particle also. It has a very good quality of absorbing uh, the very good quality of absorbing other particle. So these ions are basically simply absorbed by the suspended particle, and suspended particle also get charged. Either it may be positive or negative charge. So now these products are quite effective as a coagulant, as they absorb very strongly onto the surface of the most negative colloid. So basically these ions are basically absorbed by the suspended particles, and particles also get charged. Now once particles are charged, so we have to destabilize the water, destabilize the ions, so that the collision happens. Once collision happens, the dimension of the particle will increase, right? So the destabilization of aluminum and iron accomplish destabilization by two mechanisms. Basically, there are the two mechanisms where the destabilization happening. First one is the absorption and the charge neutralization. The first step is, as I mentioned, the small suspended particles will absorb those ions, and the second one is that immersement in sweep flock. So this type of flock ones will produce into the water, and those uh, basically those type of flocks will settle down at the bottom after some time. Yeah, so now you understand. So these two methods, two mechanisms actually it follows for the destabilization of the water. So ultimately when the flock forms, basically, or this flock is actually deposited. Flock means when the particles are added together, that we call it flock. So flock will have a more mass, so that they will be simply settle down at the bottom. So the interrelation between pH, coagulant dosage, and the colloidal concentration determines the mechanism responsible for coagulation. What does it mean? Means, for example, this is a tank. You can understand here water is there, and these particles are suspended. These small particles. Let me draw it here. So these small particles are actually suspended into the water. So what we do? We add the chemicals, right? Coagulants we call it. So we added extra some quantity of coagulant. So now the reaction will take place and the settlement will take place. So now the entire destabilization mechanism depends on three things. One is what is the pH of the water. If pH is more, then one type of mechanism will be happening. If pH is less, then another type of mechanism will be happening. Similarly, how much quantity of coagulants or how much alum or any chemicals, basically coagulant chemicals, you have added to the water, and how much suspended particles are present in the water. So these three things are actually determines how the mechanism, I mean, how the destabilization will be happening inside the water. So the charge on hydrolysis product and the participation of metal hydroxide are both controlled by pH. Okay, so this reaction in the last slide I have shown one reaction also, right? So these reactions will be happening depending on the pH. This is controlled by pH. So we have to check what is the pH content of the water, and accordingly that we have to add the coagulant dosage, and then the reaction will be takes place. So this equation you see, so based on this equation, basically the entire thing is happening, and when the ions are charged on the particles are positively or negatively charged, what will happen? These two, three will combine together and it makes the flock. The flock is nothing but when it combines, it aggregates all the suspended particles, and the dimension increases, that we call it flock. Once flocks are formed, it will be simply deposited at the bottom. So these are the expression. You can see how the reaction takes place inside the water, and ultimately how the destabilization takes place and the deposition takes place at the bottom. So now The another important parameter, another important concept here is the how much will be the dosage of coagulant. Now you understand. Till now, what we have understand is right. This is our tank, and the water is there, and we have these suspended particles. So we have to add coagulant into the water, and this coagulant will take the reaction, and it will form the flock. Is not it? So how much coagulant you will add? That is the next question. So in a water treatment plant, you understand now water is coming from addition tank to primary sedimentation tank. From primary sedimentation tank, it comes to secondary sedimentation tank, where we add this extra chemicals, that coagulants. Now, how much coagulant will you add? So that is the next question. So this how much coagulant you add, that is determined based on this jar test. So the jar test is done on a laboratory to determine the optimal operating condition for water or wastewater. Means how much optimal values you have to add, how much optimum quantity of coagulant you have to add. So this method allows the adjustment in pH. As I have mentioned in the last slide also, the reaction takes place. So that reaction is depends on the pH, how much pH content is present in the water. Also, the how much concentration of suspended particles are present into the water. So this method is using jar test. Basically, here we are finding out the optimal coagulant content, how much we have to add it into the water. So this method adjusts in pH, variation in coagulant or the polymer dosage, alternating mixing the speed. Means again we have to speed, right? We have to mix it. We have seen in the last lecture also. That is theory part, theory of flocculation and coagulation. In that, once you add the coagulant, we do the rapid mixing and the slow mixing also. So what will be the speed of this mixing? So all these things has to be find it out, because this everything depends on the quality of water. So all water don't have the same pH value, right? If you collect a water from a river Godavari and if you collect a water from river Ganga, so both the water will have different pH value, isn't it? And both the quality of water, both the water will have different concentration of suspended particles. So based on this jar test, so we have to perform the jar test with the Godavari water as well as the Ganga water, and then we have to finalize the optimal content, optimal pH value, or optimal coagulant dosage, and how much will be the speed, mixing speed, right? So all these things has to be finalized, and using this jar test, basically we are doing all these things. So this is the apparatus you can see, that is jar testing apparatus. How? So this is the apparatus here. Total 6 number of this type of jars will be available. So each jar inside that this type of pedal will be there, right? So in this jar test, what we do? This jar testing apparatus consists of 6 pedals, right? Which treats the content of 6 1 liter containers. So each container's dimension is only 1 liter. Means 1 liter liquid it can contain. So one container acts as a control, while the operating condition can be varied among the remaining 5 containers. So one container will have original real water, I mean the original water, and other container basically will add the coagulant in some percentage. So in one jar, maybe you add 1% or 1% of coagulant, another maybe 2%, 3%, like that. In different 5 jars, you add 5 different percentage of coagulants. And also these are connected with a pedal, right? So all jars can be stirred, means all using this pedal, basically we can make the destabilization, we can make the rapid mixing, right? So all will have a different speed it can move, or maybe on same speed it can move. So depending on our experiment, we choose the speed of this pedal also, and then we notice that which filter, which the container deposits more quantity of particles. So based on this jar test, basically we are finalizing how much quantity of coagulant has to be added, and also what is the speed of this pedal. All these parameters we have to add it. All these parameters we have to finalize using this jar test. So what is the procedure for jar testing? So jar testing procedure involves the following steps. So you understand, first is to fill the jar testing apparatus container with the simple water, right? Simple water means like Ganga water or Godavari water, from where you are collecting the water. So one container will be used to control, while other 5 container can be adjusted depending on the condition are being tested, right? So that's what. So other 5 container, basically we can adjust it, right? In some container we add little bit coagulant 1%, another container 2%, some container we add little bit some chemicals to increase the pH value, some container we add little bit some chemicals to reduce the pH value, some will be rotating very high speed, some will be rotating very low speed. Like that, multiple combinations we add, and we can do that. So add the coagulant at the each container and stir approximately 100 revolutions for 1 minute. So 100 revolutions per minute at a speed of, we are setting, and we are rapid mix we are doing basically. So once rapid mixing done, then we keep it on constant for the 30 to 45 minutes. That means the settlement will take place. Now the flock will form and settlement will take place in this 30 to 45 minutes. Now the water is on rest, right? Now the reduce. So now again we find it out. So at the bottom, basically the suspended particles will be deposited at the bottom. So now you can measure it, how much quantity of particles has been deposited at the bottom. So like that, multiple trials and errors basically we have to do it, and you have to find it out the optimal coagulant content, as well as the pH value of water, as well as the speed of mixing the coagulant into the water. So all these parameters you have to finalize using the jar test. So jar test is a laboratory experiment. In a laboratory we do this testing, and once the values are finalized, then we deploy it on a water treatment plant, and then we uh, the water treatment will be live. So basically in this jar test, we plot residual turbidity. Residual turbidity means how much suspended particles are deposited at the bottom. That is, the residual means how much is the residual, right? Versus coagulant dosage means how much you added the coagulant. Then plotted and optimal condition are determined. So you add 1%, 2%, 3% coagulant gradually. After you start, after in the experiment you will see, even after you add more coagulant, the solubility or the deposition of this suspended particle will be same. It is not increasing. So that you can take it as the optimal constant, optimal value, and that dosage will be applied into the actual water treatment plant. So in this lecture, basically what we have understood is the flocculation and coagulation final part we have understood. So in last three lecture we are debating in the secondary sedimentation tank, that is coagulation and filtration process, coagulation and flocculation process. So in details we have discussed in this concept. So now in the next lecture we'll be discussing about the filtration part. So even after suspension, even after we remove these small colloidal particles present in the water in the secondary sedimentation tank, still there will be very fine particles present in the water that won't deposit even if in the secondary sedimentation process also. So in the next step, water will go to filtration process. Now I'll just quickly draw how much we have done it. So you have, this is the water river stream. So from there basically we are collecting the water. Water came into water treatment plant. So the first step is, here we are screening. Screening means all the floating material will be retained. Then water will come into our aeration tank. So first one is the aeration tank. After aeration tank, water will go to primary sedimentation tank. After primary sedimentation tank, water will go to that coagulation flocculation small tank where the rapid mixing takes place, and then it will go to another secondary sedimentation tank. There it will stay for 1 or 2 hours, so that flock will form and it will be deposited at the bottom. So this is the secondary sedimentation tank, and this one is the primary sedimentation tank. Then after secondary sedimentation, water will go to next step, that is the filtration. So next lecture we'll be discussing the filtration in details. So after filtration, basically water will be, all the solid particle will be removed from this water, after the filtration, and then water will go to next step, that we call it disinfection. Means we have removed all the solid particle present in the water, but still some bacteria, pathogenic bacteria still will be present in the water. So that will be removed in the last step, that is disinfection. So after disinfection, water will go for the distribution purpose. So now you understand the entire flow diagram of water treatment plant. We collect the water, first is screening, then aeration tank, then you have the primary sedimentation, then you have the flocculation chamber, the coagulation chamber, rapid mixing will be happening here. Then it will go to secondary sedimentation and it will rest for some time. So the clean water will go to filtration. After filtration, water will go to disinfection, where we clean the bacteria, right? We kill the bacteria from the water, and then water will be purified for the drinking purpose. It will be distributed into the household. So that's how the actual step, and that we'll be covering in this course. Thank you.